Functions and function notation. Now listen, you guys have been changing things into function form. You've heard me use the word function. Now I want to talk about functions, define them for you, talk about parts of functions, talk about function notation, which is really the naming of functions. All right, we'll get to that in just a minute. But any set of ordered pairs is a relation, okay? A relation is any time we put two numbers together, an x and a y, -3 and 4, these two things are related, okay? When we graph all of the ordered pairs in a relation, sometimes they're functions, sometimes they're not. They're always relations, but there are some specific restrictions for it to be a function, and we'll talk about that in just a minute. So a relation is just any set of ordered pairs, okay? Now, a function is a rule that shows the relationship between two numbers, okay, between an x and a y. These two numbers are called the input and the output. Clay, let me ask you, and it's just really a guess for you, or you may have heard this before. Which variable in x and y, which one is the input?
The input,
Let me ask, go back to doing a table of values, right, to graph an equation.
also the x.
It's x, right? Those are the three that we pick, and we put them in, and it spits out a y for
And
us,
y
right?
is the output.
Exactly. So y is going to be the output, okay? The x is the input, and the y is the output, okay, for a function. All right? Now, the next thing is the domain. The set, or the collection, of all the inputs is called the domain, okay? So the x coordinates would be the domain. Range. The set or the collection of all the outputs. So when we put it in a t-chart, we got x's on one side, we got y's on the other, right? All of the x's, that's the domain. All of the y's, that's the range. All of the x's are called inputs. All of the y's are called outputs. Okay? Now, I know you can see down here this big capital letter rule for a function. Well, let me just read it as I have it here. Here's a rule, an important one, okay? An input can have only one output in order to be a function, okay? So when I put a number in, I can only get one number out. Can two different numbers, when I put them in, is it okay if those two different numbers give me the same output? That's okay. But one input cannot have two different outputs, and I'm going to show you in a minute just what that means and why it's true.
Can you show us
Okay?
graphically?
I am going to show you graphically. Yeah. Okay? Now, this last bit down here, let's talk about this. This is function notation. Another name for y is f of x. Okay? Now let me explain what I mean by that. When we put things into function form, they look something like this. Y equals -1/2 x plus 2. Okay? That one's in function form. All right? Because we got y by itself, we've got the number with x first, and then we've got the constant behind it. Here's another function. Y is equal to 3/4 x minus 7. Here's another function. Y is equal to -4/3 x plus 5. Okay, that's three different functions. Now, sometimes we might want to graph these things on the same coordinate plane. We want to compare it. We're comparing these different functions. Okay? But the problem is that once we start graphing them, it's hard to tell which one's which. We have to look back at the function, figure out what's going on. Okay? So instead of saying y equals, we actually give these functions names. We can call this one the function of x is that stuff. That's what we do to x. But now I've got another one. All right, well, let's just make that g of x. This one's h of x. These are just different names for the functions. Okay? Now this is cutting me off.